Very good morning, all of you. Today we have go to a second lesson, kinematics. Kinematics. Already we have discussed what do you mean by kinematics in previous lesson or first lesson. Because of the we are discussed the branches of physics in and its types. So kinematics is nothing but it is the branches of mechanics which deal with the motion of object without taking a force. This word comes from kinema, which means motion. In this lesson, we are going to see about some few topics, but in this lesson, the learning objectivities provide what are we are going to see in this lesson. First of all, first content we are going to see about different types of motion. In physics, motion is nothing but change with time of position or orientation of the body, or otherwise change of the object with respect to time or orientation of the body. Okay, good. Here various types of motion is provided. First of all, we have see the motions in linear, rotation and oscillation, and second we are going to see the necessity for reference frames to explain the motion of objects, and third one, the meaning of vectors, scalars and the properties, and fourth one, the role of scalar and vector products in physics. And we are going to move the next topic, the basis of differentiation and integration. This is the most important topic in our entering in the 11th standard, also in mathematics subject 2. And next, the notions of displacement and distance and the variations with respect to time, and notion of relative velocity, and the most important topic of kinematic equations of motions for constant acceleration, and various types of motion of object under gravitational force, and radians and degrees, and finally the lessons end with the chapter of uniform circular motions and centrifugal acceleration and centripetal force. These are the content we are going to see the lessons of kinematics. So introduction about this lesson. Physics. We know that physics is basically an experimental science. In this lesson, there are the two pillars and important of kinematics is one is experiments and another one is mathematics. 2300 years ago, the Greek librarian Eratosthenes measured the radius of the earth, and the size of the atom was measured much later, only in the beginning of the 20th century. This is the central aspects in physics is motion. Motion is found at all levels from microscopic level. Microscopic means already we know that within the atom, which means smaller in size, to macroscopic and galactic level, which means the planetary system and beyond, implies that the larger in size. In short, the entire universe is governed various types of motion. The study of various types of motion expressed using the language of mathematics. Here, how the objects of move fast or slow they move. For example, when an athletes run in a race, all of them do not run in the same manner. The performance cannot qualitatively recorded by the usage of words like fastest, faster, average, slower, and slowest. It has to be quantified. Quantifying means assigning numbers to each athlete's motions, comparing these numbers one can analyze how fast or slow each athlete run when compared to the others. In this unit, the basic mathematics needed to for analyzing motions in terms of its directions and magnitude is covered. So finally we go to see what do you mean by kinematics. Kinematics is already we tells in the beginning of this starting of the lesson. Kinematics is the branch of mechanics, deals with the motions of an objects without taking force into account, which means அதாவது இங்கே என்ன சொல்லிட்டாங்கன்னா, ஒரு ஆப்ஜெக்ட் இருக்குது, அந்த ஆப்ஜெக்ட் மேலே நம்ம ஃபோர்ஸ் அப்ளை பண்ணால் மட்டும்தான் அந்த ஆப்ஜெக்ட் கேன் பி மூவ். இங்கே நம்ம அதாவது பார்க்கும்போது என்ன சொல்கிறாங்கன்னா, ஆப்ஜெக்டோடைய மோஷன்ஸை மட்டும்தான் நம்ம கன்சிடர் பண்ண போகிறோம், நாட் இன் த ஃபோர்ஸ் அது அந்த மோஷன்ஸுக்கு ரீசனாக இருக்கிற ஃபோர்ஸை பற்றி நம்ம பார்க்க போகிறது இல்லைன்னு சொல்கிறாங்க. ஸோ தட்ஸ் வை இஸ் கால்ட் அஸ் கைனமெட்டிக்ஸ். த வேர்ட் கம்ஸ் ஃப்ரம் கைனமா, which means motions. And second, the concept of rest in motion. Here a diagram will be provided here. See clearly frame of reference the topics. This concept of rest in motion can be understood by the following elucidation. The word elucidations means tells us to making clear. This is the meaning of elucidation. In this diagram tells us a person sitting in a moving bus is rest with respect to the fellow passenger, but its motion with respect to the person outside the bus. அதாவது இங்கே என்ன சொல்கிறாங்கன்னா, ஒரு பஸ்ஸில் ஒரு பர்சன்ஸ் இருக்காங்க, அது பார்த்தீங்கன்னா மூவிங் பஸ். அவர் பார்த்தீங்கன்னா அந்த பஸ்ஸில் பார்த்தீங்கன்னா உட்காந்துட்டு இருக்கும்போது த பர்சன்ஸ் வில் பி ரெஸ்ட். அவர் என்ன பண்ணுறாருன்னா ஓய்வு நிலையில் இருக்கிறார். யாரை டிபெண்ட் பண்ணால் அந்த பஸ்ஸுக்கு வெளியில் இருக்கிற ஒரு ஸ்ட்ரேஞ்சர்ஸ், யாரோ ஒரு எக்ஸோ ஒய் இசோட் அவரை பொறுத்து அவங்க பார்த்தீங்கன்னா ரெஸ்ட் பொசிஷனில் இருக்காங்க. அதே பர்சன்ஸ் அந்த ஸ்ட்ரேஞ்சரை பொறுத்து அந்த பர்சன்ஸ் அந்த பஸ்ஸுக்குள்ளே இருக்கிற பர்சன்ஸ் என்ன பொசிஷனில் இருக்காங்கன்னா மூவிங்கில் இருக்காங்க. ஸோ அப்போ என்னென்னா டிபெண்டிங் அப்போ அந்த ஃப்ரேம் ஆஃப் ரெஃபரன்ஸ் ஒரு நிலையை பொறுத்து தான் அவங்க என்ன பண்ணால் ஓய்வு நிலையில் இருக்காங்களோ அப்படி இல்லைன்னா இயக்கத்தில் இருக்காங்களோன்றதை பார்த்தீங்கன்னா இந்த டயக்ராம் சொல்லுது. ஸோ வி நீட் ஏ ஃப்ரேம் ஆஃப் ரெஃபரன்ஸ் டு அண்டர்ஸ்டாண்ட் த கான்செப்ட் ஆஃப் ரெஸ்ட் ஆர் மோஷன்ஸ். அதாவது ரெஸ்ட்டை பற்றியோ அப்படி இல்லைனா மோஷனை பற்றியோ நம்ம படிக்கிறதுனா கண்டிப்பாக நம்மளுக்கு கன்வீனியண்ட்டான ஒரு ஃப்ரேம் ஆஃப் ரெஃபரன்ஸ் தேவைன்னு அப்படின்னு சொல்கிறாங்க. ஓகே, குட். ஃப்ரேம் ஆஃப் ரெஃபரன்ஸ், திஸ் இஸ் அன் இம்பார்ட்டன்ட் 2 more questions. Frame of reference. If we imagine a coordinate system and the position of an object is described, the relative to it, such a coordinate system is called as frame of reference. Here this diagram, at any instant of time the frame of reference with respect to which position of the object described in terms of position coordinate axis x, y, z, y, z. These are the coordinate system is called as Cartesian coordinate system. And this diagram, it is to be noted that if x, y, z axis is drawn in anti-clockwise direction, which means this direction, anti-clockwise direction, this Cartesian coordinate system is called as a right-handed Cartesian coordinate system. Once again I repeated the terms. If the Cartesian coordinate system can be drawn in the anti-clockwise direction, this is an anti-clockwise direction, the anti-clockwise direction Cartesian coordinate system is called as a right-handed Cartesian coordinate system. Some of the example will be given in our books. The first one, anti-clockwise direction, so we called as right-handed Cartesian coordinates. And second one, clockwise direction, so left-handed, z is in upward direction. And third one is anti-clockwise direction, so right-handed, y is in up direction. And fourth is clockwise direction, so left-handed, y is in up directions. Next topic, point mass. to explain the motion of an object which has a finite mass. The concept of a point mass is required and is very useful. Let the mass of an object to be assumed to be concentrated at a point, then its idealized mass is called as point mass. It has no internal structure like shape and size. Mathematically, a point mass has a finite mass with 0 dimensions. So, point mass has a dimensionless. Even though the reality of a point mass does not exist, it often simplifies our calculations. It is to be noted that the terms of point mass is a relative term. It has meaning only with respect to a reference frame with respect to the kind of motions that we analyze. For example, to analyze the motion of Earth with respect to Sun, Earth can be treated as a point mass because the distance between Sun and Earth is very large when compared to the size of the Earth. In second example, if we throw an irregular object like a small stone in air, to analyze its motions is simpler to consider the stone as a point mass. As it moves in space, the size the stone is very much smaller than the distance through it when travels. And we are going to see types of motions. Here various types of motions will be seen in our day-to-day life. First of all, we go to see the linear motions. Linear motions. Linear motion is nothing but an object is said to be a linear motion. It moves in a straight line. For example, an athlete running on a straight track, and second one, a particle falling vertically downwards to the earth. And second, circular motions. Circular motions is defined as the motion described by an object traversing in a circular path. Traversing means to crossing the path. This is a circular motions. For example, the whirling motions in a stone attached to be a string. And second one, the motions of a satellite around the earth. These are the two circular motions. And third one, rotational motion. Rotational motion. Rotational motion means if an object moves in a rotational motion about an axis, the motion is called as rotation. During rotation, every point in the object transverses in a circular path about an axis. For example, the first one, rotation of a disk about an axis through its center. The second one, spinning of the earth about in wood axis. These are the two examples of rotational motions. And fourth one, vibratory motions. Vibratory motions tells us if an object or a particle executes to and fro motions about a fixed point is said to be a vibratory motions. This sometimes is called as oscillatory motions. For example, the first one, vibrations of a string on a guitar, and second one, movement of a string. And we are going to see the next topic of dimensions. This means motions in 1 or 2 dimensions or 3 dimensions. Let the position of the particle in space to be expressed in terms of rectangular coordinates like as x, y and z. When these coordinates change with time, then the particle is said to be a motion. However, it is not necessary that all 3 coordinates should together change with time. Even if one or two coordinates changes with time, the particle is said to be in motions. Then we have following classification. We are going to see about first in motions in 1 dimensions. One-dimensional motion is the motion of a particle moving along a straight line. The motion is sometimes known as rectilinear or linear motions. For example, a car moves from a position A to B along x direction, shown in the x coordinate only. For example, moving of your train along straight rail track. In second one, an object falling freely under the gravity close to the earth. Second, motions in two dimensions. A particle is moving along a curved path in a plane, then it's said to be in a two-dimensional motion. In this motion, two of three rectangular coordinates specifying position of the object change with respect to time. For example, motion of a coin on a carom board, an insect traveling over the floor of a room. And third one, motions in three dimensions. A particle moving in a usual three-dimensional space has three-dimension motion. In this motion, example for a bird flying in the sky, random motions of a gas molecule, flying of a kite on a windy day. And then going to see an important topic, elementary concepts of vector algebra. This is the most important one. In physics, some quantities possesses only magnitude and some quantities possesses both magnitude and direction. To understand these physical quantities, it is very important to know the properties of vectors and scalars. First of all, we are going to scalar quantity. Scalar quantity is nothing but it is the property which can be described only magnitude. In physics, a number of quantities can be described by scalars. Scalar means they have only contains of magnitude, which means a numerical value. For example, distances, mass, temperature, speed and energy. In second one, vector quantity. It is a quantity which is described by both magnitude and direction. Geometrically, a vector is directed a line segment. See the diagram. In physics, certain quantity can be described only by vectors. So vector quantity is nothing but they have contains of both magnitude and direction. So for example, in vector quantities of force, velocity, displacement, position vector, in acceleration, linear momentum, and finally angular momentum. These are the examples of vector quantity. And we are going to the next topic, magnitude of the vector. Magnitude of the vector. The length of a vector is called as magnitude of the vector. A vector is providing here the diagram of 2.11. The length of the vector is called as magnitude of the vector. It is always positive quantity. Sometimes the magnitude of the vector is also called as norm of the vector. For a vector, E vector, the magnitude or norm is denoted by the symbol of norm vector or simply E. Next topic, different types of vectors. First one is equal vectors. Two vectors A vector and B vector are said to be equal when they have same magnitude. The length of the two vectors will be same and they have same direction. This is called as equal vectors. And in second one, collinear vector. Collinear vectors also which act as along same line. The angle between them can be 0 degree or 180 degree. In Roman letter 1 will be seen as parallel vector. If two vectors A and B vector act at the same directions along the same line or parallel lines, then the angle between them is 0 degree. The diagram is provide the angle between the both of the vector is 0 degree. And anti-parallel vectors, second one. These two vectors A and B are said to be anti-parallel when they are opposite direction along the same line or parallel lines. Then the angle between them is 180 degree. Both of the vectors will providing the angle between of A vector and B vector is 180 degree. And third one is important one, Second one is unit vector. A vector is divided by its own magnitude is called as a unit vector. The unit vector A vector is denoted by A cap or hat. It has a magnitude equal to unity or 1. So A cap equal to A vector by E. Thus we can say the unit vector specifies only the directions of the vector of quantity. The third one is orthogonal vector. Let I cap and j cap and k cap are the three unit vectors which specify the directions along x-axis, positive y-axis and positive z-axis respectively. These are the three unit vectors are directed perpendicular to each other. The angle between the two vectors is 90 degree. And I cap and j cap and k cap are the examples of orthogonal vectors. Two vectors which are perpendicular to each other is called as orthogonal vector. Orthogonal vector is nothing but the two vectors which are perpendicular to each other. Thank you.